Okay, I just want to talk and give some information that'll probably help with answering a question like this question 5 here. So this here is a 6-mark question where what it's asking you to do is to describe and explain. Okay, describe and explain how the force of gravity changes during the orbit of a comet. Okay. And to use our knowledge of forces to describe the effect. Okay, so first things first, we're going to look at how does gravity change for an object in space. Okay, so what I'm going to do is a quick little sketch. So we've got the sun here. Okay, so we've got the sun. Okay, now what I saw was a lot of people saying things like there's no gravity in space. And that is absolutely not true. Okay? There's gravity everywhere. Okay? Everywhere at all times. Okay? What's different is that when you're close, okay, when you're close, there is the gravity is much stronger. Okay, gravity is very strong. Okay, however, if we're really far, okay, gravity is very weak. I'm just going to say much weaker. Okay, so when we get farther away, there's less gravity. Okay, and remember, gravity is always pulling as a force towards the center of the object, whatever's making it. So in our example here, we're looking at a comet and the sun. So if we look at this, okay, and I put the sun here, okay, and I draw the orbit, okay, so we're really far. So the picture is a little bit misleading, because really for a comet, what you're going to have is one side where you're really far. Remember, and that means less gravity. And here is the closest, and it's more gravity. Okay, so the force is really big when we're far away. Remember, the comet is traveling around this way. Okay, and it keeps orbiting forever. Okay, now when something is really, really far away, when it's taking this path, okay, so what's happening is that here it's moving away from the sun. Okay, so it's getting farther away. So because it's moving this way, but gravity is pulling this way, okay, that's going to slow it down. And here, because we're moving towards the sun, it's going to be speeding up. So when we're really far away, it's actually moving really slowly, okay? Because it's slowing down. Where it's closest, it's the fastest, okay? That's because basically it's fallen towards the sun from really, really far away. So because it fell from really far away, it had a lot of time to get faster. So if I take an object, okay, and I lift it up a little bit, and I let it drop, not a lot of sound. If I lift it up really high, a much louder sound, okay? That's because it had more time to fall, and it picked up more speed, okay? And just the way that everything works, we have it being the fastest, but that makes it turn really quickly, okay? So it changes its speed. So it spends a lot of time far away. It speeds up as it moves towards the sun. You have more gravity. As it's getting closer, and you have less gravity as it's moving away. Okay? So your key points are that when it's closest, it's moving fastest. That's when it has the most gravitational force. Okay? So fastest and most gravitational force when it's closest. It has the least amount of gravity when it's far away, and this is also the slowest. Okay? That should be enough to help you try to describe and explain how the force of gravity changes and look at how how this affects the speed of the comet. Okay? So I want you to give that a shot, and hopefully it all works out well.